All right, y'all, we're going to be talking about power of a point today. Power of a point is a really useful tool for finding missing segment lengths in or outside a circle. And we're going to start with some pretty basic problems and then for today, and then we may move on to some more complicated ones tomorrow and beyond. So what we see in this first problem is a point at the middle, and I'm going to circle that. This is kind of our key point. Now, power of a point is a theorem that states that this length to the point times this length to the point should be equal to the product of this length times this length, which means for us that 10 times 4 should equal 5 times x. So what that means is that 40 equals 5x, which of course means that x equals 8. And that's our theorem. And as you can see, the math is not too bad. So let's look at our second problem here. Now, this is a slightly different case, but again, the same idea applies. That is not the one I wanted. Let me erase that. And let's go back to the actual pen. So again, the idea here is that we have a single point, and it meets the circle here, and it goes all the way to the circle there. So we have 1, 2 meetings with the circle, just like up here we had 1, 2 distances to the circle. That can be a little tricky to figure out, but basically what we're doing is 6 times this entire distance, which is actually 6 plus x. Okay? Now on the other side, I'll do this in red. We've got 7 as our first length, 18, which is 7 plus 11, as our second length. So I'll write that out as 7 times 18. Okay? Now we've got to do a little math. So we got 36 plus 6x on one side. And on the other side, we got, let's see, 70 plus 56. So that's 126. If we subtract 36 from both sides, we get 6x equals 90. And x then equals 15. Cool. Let's look at the next problem. This is going to be another outside one. Now, this is a funny one because the one side meets the circle twice at the same point. So this distance was x. I'm actually going to erase so you can see that. This distance was x, and we actually use it twice. So we have the first distance is x, and the second distance has to be x again. So we've got x on this side times x equals, and then on the flip side, we got 27 here, and let's see, 48 here. That's going to be some big addition. So I got 27 times, it looks like 75. Now, this is going to give us x squared equals 27 times 20 times 75. I'm actually going to do something odd here. And I'm going to write this as 3 cubed times 3 times 5 squared. So you notice we actually factor everything. We can see that x squared equals 3 to the 4th times 5 squared. And if we take the square root of both sides, what we're going to get is x equals 3 squared times 5, which is 3 squared is 9 times 5 is 45. Okay, so that's just a slightly easier approach to take in that case because the numbers are so big, and I'd prefer to keep them small. Let's look at number 7. So what we've got going on here is a more basic case for what we saw in the first problem, where we have this guy times this guy equals this one times this one. Okay, so we can just write out that one. We're going to see 8 times 4x plus 1 equals 6 times 6x. So that looks like it's going to give us 32x plus 8 equals 36x. And if we subtract 32x from both sides, it's going to give us 8 equals 4x. And then x must equal 2. All right, power of a point. So let's look at now the even problems on this page. And we're going to jump back to a pretty easy one at this point. So what we see is 6 times x equals 9 times 8. So 6x is going to give us 72. If we divide both sides by 6, we should get x equals 12. Cool. Oh, I can box that. All right, let's look at this next one. This is one of those cases with a tangent, so we got to count this segment twice. So we're going to see 6 times 6 equals 4 times 4 plus x. So if we do some multiplication here, we're going to see 36 equals 16 plus 4x, which means 20 equals 4x, which means x equals 5. Sweet. With this next problem, it's going to be a very similar case, except now we got an x squared going on. So we're doing x squared, that's that left side, equals 4, which is this first length, times 4 plus 5. So that's actually going to give us 4 times 9. And then x squared must equal 36, which means x equals 6. Alrighty. Let's look at this last problem on this page, number 8. So here we've got an x plus 4 twice. That stinks because now we're going to have to square a binomial. And that's going to equal x plus 1 times x plus 8. Okay, that stinks. So this is a good one to end on because it's one of the most complicated that we've done. So if we square this binomial, what we're going to get is x squared plus 8x plus 16. And that's going to equal x squared plus 9x plus 8. Okay, so first things first, let's just get rid of the x squareds. Don't really want those there, and they're just going to complicate things. So now we're left with 8x plus 16 equals 9x plus 8. Let's just take off 8x from both sides, which is going to leave us with 16 equals x plus 8, which of course means x has to be 8. And there's our set of problems. I may come back and do some of the more complicated ones for day 2 of Power of a Point, but for now we'll stop there.